So in example 3 is where we were, right? Solving logarithmic equations. Okay? So a couple different ways I can go about this here. Kids, if you look at the first equation up there, it says we have the natural log of 5x plus 2 is equal to the natural log of x plus 10. Now, if I would give you an example like this, I said, hey kids, suppose I have the natural log of 14, come on, equals natural log of 2x. Anybody want to take a guess at what x would equal to make that a true statement? How much? Yeah, has to be 7 because we want the natural log of 14 to equal the natural log of 14. So when I have one natural log equal to another natural log, the parts in parentheses need to be equal to each other. So in the example we're looking at here to solve this right here, this is actually pretty simple. Anybody have a guess what we might set equal to each other if I have natural log of 5x plus 2 equal to natural log x plus 10? You may have a guess? Yep, we're just going to set 5x plus 2 equal to x plus 10 in this example. And say, all right, well, let's solve for x. So I'm going to subtract an x from both sides. We're at 4x plus 2 equals 10. Gosh, if I subtract the 2, 4x will equal what here, kids? Yep. So what's that make the x value? Okay, so I've got x equal 2. Now, guys, you're going to start getting in a habit. You know, part of our vocab on Friday was what an extraneous solution was. One thing you're going to want to do is always take any solution you get, put it back in to see if it's validated. Okay, guys, if I take the 2 and plug it in up here on the left side, what's 5 times 2 up here? 10 plus what? This becomes a natural log then really of what value? On the right side, if you plug in the 2 up there, the right side becomes a natural log of what? Natural log of 12 is going to equal the natural log of 12, kids. So pretty good chance x equal 2 has to be correct there then, right? How do you feel about that? You okay with that? So what I'm telling you is this. If you ever have a logarithmic equation where you have one log on the left, one log on the right, take the parts that are in what? And set them equal to each other. Okay? Very similar to what we had when we had common bases. Okay? If you have common logs, set the parts in parentheses equal to each other. Okay? Now, kids, are there logs on both sides of the next equation? Absolutely not. Okay? Now, if this happens right here, what I would maybe tell you to do is to take a logarithmic equation, this, and write it as an exponential equation. So what I could do here in this next one, kids, is this. First of all, what is the base in here? Okay, this is like saying 3 to what power? So this is the same as saying 3 to the 4th is equal to my value in parentheses, in this case, 10x minus 9. Okay? So if you have one logarithm like this and you have to solve for x somewhere, it's probably a good idea to take a logarithmic equation and write it as an exponential. So by this rule right up here, kids, log base b of some value is your exponent. So I can write this as my base b to my power equals that value. In this right here, what's the base again, kids? So 3 to what power? 3 to the 4th. If I change it from logarithmic to exponential, 3 to the 4th would have to equal what? 10x minus? Well, I have a question. Take a look at that 3 to the 4th part. How much? Yeah, I can evaluate 3 times itself 4 times. It is 81. So now I'm at the point 81 equals 10x minus 9, kids. Hey, that's a 2-stepper. What do you guys get when you solve x? How much t? I couldn't hear you. 9, you bet. X equals 9 when you solve this, okay? if you have a single logarithm, it might be a good idea to change that logarithm to a what? Exponential, okay? Guys, there's so many rules up here. You're just going to have to play around at times. And I think the more that you practice this stuff, the better you're going to get. You're going to get an opportunity in the quick quiz to work this stuff. I think you're going to do great, though, okay? So I look at example 4 and I think, oh my gosh. Are there multiple logarithms? Yeah. Are there multiple logarithms? Is there a logarithm on both sides of the equation or just one side of the equation? Oh boy, so I'm going to start thinking. My gear's spinning. What am I going to do here? We'll take a look at this previous one right up here. We only had logs on one side. Was it good to have a single log or many logs up here on the left side? So condensing something would be a good idea, wouldn't it? Is there any way I can condense the left side to write, instead of 2 log base 6s, is there any way to condense everything on the left to just 1 log base 6? Shout it out to me, kids. I'm going deaf. At age 44, I'm going deaf. I put my wireless Boses in on the weekend and they're too loud, so I can't hear you. So you need to help me. Shout it out. Multiply. Who said multiply? Jasmine, speak up, kid. Yell at me. What are we going to do here, kiddo? You're right. You're right, by the way. That's awesome. Yeah, I have addition right here, so I can turn these 2 logarithms into 1 logarithm of what operation? Jasmine, I think you said multiply, right? I have to take 6x times what? So we have to distribute that, okay? So I'm going to go 6x times x would be what, kids? Minus I want you to be careful on something like this. I want you to be very careful on something like this. Inside of parentheses, there is subtraction. So does that mean this turns to division right away? Or do we leave it as is? I'm actually going to leave this the way it is because the log base 6 is applying to everything here. The only time I change subtraction into a single logarithm of division is if I have 2 logs. Well, do I have 2 logs here or just 1, kids? Okay, so the only thing I can do now, kids, is leave it as is. And we're going to take this example and we're going to apply exactly what we did up here in the top right. So I'm going to say, first of all, what's the base, kids? We're going to change this logarithmic function into an exponential. So we're going to say 6 to what power, kids? Okay, 6 to the second is going to equal our value of what here? Okay, but what is 6 squared though? Right? Oh my gosh, kids, what kind of function is this looking like it's going to be? Let's get this to equal 0. So I have 6x squared minus 6x minus 36. What power do I have up here? We could factor that, or you can use your quadratic formula calculator that you have in computer. Okay? Anybody have access to the quadratic formula calculator right now? Who's in there? What am I going to type in for A here, kids? How about B? And what are you going to plug in for C? Okay, are you running those numbers right now, Jazzy? Okay, so she's going to plug this in. So I'm going to write down over here by QFC, which stands for what, kids? Not Kentucky Fried Chicken. Quadratic formula calculator, yes. Kentucky Fried Chicken. Hello. 3 and negative 2 is what I like right there. We get x values of 3. Now, kids, here's the tricky part. If you recall your vocabulary, one of the vocab terms up there was what? What type of solutions? Extraneous, okay? What I want you guys to do is this. Basically what I want you to do is plug stuff in, okay? And what I'm going to tell you is this. Just go up here to your first part right here, all right? I know the base is 6, and that's okay. I'm not going to worry about that too much. So what I want you guys to do is this. What would 6 times 3 get you? Okay? Or better yet, let's do this. Let's do this. Let's go back to this part right here and substitute stuff in. The part that's going to be problematic, actually I don't want to do that. I want to go back to the original one. Go back to the original one right here. Okay? Type in log of 18 in your calculator and see if you get a value. Log of 18, just type it in. 1.255. So you get some number, right? Okay. Now if I plug the 3 in here, what would 3 minus 1 get you? Type in log of 2. Does that give you some value? It works, okay? So anytime you plug a solution into the original part right here and go log of whatever, after you plug it in and it gives you a number, that's good. Now let me show you what's going to be very bad, all right? If I plug negative 2 in up here, this becomes a log of what, kids? Be the log of negative 12, right? Punch in log negative 12 in your calculator. Says what? Are you getting an error? Okay, here's the deal. This negative 2, when you take it back up, you can't get a situation where you're doing logarithms. You can't take the logarithm of a negative number when your bases are positive like this. So what I'm getting at is this. Ooh, I threw 3 in up here. It gave me a number. That's good. I threw 3 in this part. Did the log again. It gave me a number. That's good. But when I threw negative 2 in up here, this became the log of negative 12. Okay? Basically, this is saying 6 to some power is equal to negative 12. Well, if you start with a positive power and start taking it to changing exponent, it's always going to be positive. So right here, negative 2 would be considered what kind of solution, kids? Okay, this x equals 3 is okay, but the x equals negative 2 would be what kind of a solution, kids? Yeah, we follow all the rules of algebra. We use the quadratic formula calculator to get negative 2, but when I plug negative 2 right in here, we get an error in our calculator, which means negative 2, although found by rules of algebra, is not going to be a solution. So we call it an extraneous solution there. Okay? I think example 4 would be a really good one to put a star by. Okay? If you can walk your way through all of that, you'll know what you're doing. All right, first question. Who needs more time on this page before I move? Any questions about anything on this page before I move here? All right, last page, kids. Let's get this done. I want to give you a little bit of time to work on some things today. Looking at inequalities. This is not too bad to do, okay? First one right here says solve the inequality. First of all, what kind of inequality am I solving here? Okay, very simple to do. Very simple to do. All right? If you have an exponential, then might be a good idea to, we got to get x alone. So to solve for x in something like this, kids, might be a good idea to turn it what? Let's try it. Where would the x move to for a logarithm? I have to sneeze. Excuse me. I'm sorry. Yeah, so this would be if I log both sides. This would turn into x times what, kids? Log of 2. This would equal, or I'm sorry, this would be less than now. What? Log of what? Guys agree with my work up there so far? What I'm getting at is this. When you see inequalities to solve today, if you start with an exponential, probably a good idea to turn that into what kind of function? Log, okay? How would you get x alone here now? What would you do to both sides? Divide by, okay, check it out. I have x, log 2 divide by log 2, log 36 divide log 2. All right, I know the log 2's are going to cancel right here, kids. I do not know what log of 36 divided by log of 2 is, but I'm going to guess it's probably between 5 and 6. Closer to 5 than it is 6. 5.17. So I like going two places. X is less than. You could leave it as log 36 over log 2, or call it 5.17. Okay? Or you could say x is less than log 36 over log 2 if you want. Okay? Either one of these would work. Again, you're just looking to get x alone. So guys, take a look at number 6. What kind of inequality are we solving here? What kind of inequality am I solving there? A logarithm. Hey, we solved an exponential inequality by using logs. So they're saying you need to solve a logarithmic inequality. Might be a good idea to turn that back into an, what's the base in this logarithm for example 6? So would it be fair? Would it be fair to say, ooh, I'm a little concerned about this one. Ten to the fourth would be less than or equal to what? X. Because I put my base and my exponent here, keep the sign the same, put your x over there. All agree? Well, guess what? Let's think about this. What's 10 to the first power equal? What's 10 to the second equal? What's 10 to the third equal? What's 10 to the fourth equal? 10 to the fifth would be 100,000. 10 to the sixth would be 1,000,000. Just keep adding a 0. I don't want to be going more than 4, so we better change this. This is actually incorrect right here. You have to be very careful about solving logarithms, okay? I know that sometimes we put the base and the exponent here to rewrite this, but you have to write it in the other order, okay? We want x to stay the same. So this becomes x is actually less than or equal to 10 to the fourth. We actually put the base and the exponent on the other side there. So be careful on it, okay? To get x alone, you would have to raise this to the 10th power. So this would become 10 to the log of x less than or equal to 10 to the fourth power. What is 10 to the fourth, kids? So x would have to be less than or equal to 10,000 there, okay? Whoa. Kind of like a broken heart right before Valentine's Day. Sweet.
So why did you want to switch the x?
Well, here's the deal. To get x alone right here, you want, x was already on the left side already, right? Okay. We're so used to taking this rule right here that moves the x to the other side right here, right? You don't want to do that with inequalities. So what I'm telling you is this: to make this x go away, or to make x stay over here, you have to take it and raise it to the, so we have a rule that we haven't talked about much like this that says if I have log maybe base 5 of 2x right here, if I would take this here and make 5 my base right here, the 5 and the log 5 kind of cancel, just leaving you with the 2x. So when we had log of x less than or equal to 4, what I really did is I took both of these and made them exponents here. I called this 10 to the log of x is less than or equal to 10 to the fourth. I basically made these the powers and these the bases. So what's this 10 and log 10 really going to do to each other? Leaving us with what? And that's why it stays on the left side. 10 to the fourth is my less than or equal to a 1 followed by 4 zeros there. Okay. Again, I don't want you to confuse what we've been doing with this b to the x equals y, comparing it to log base b of y equal to x, because a lot of times the x moves to the other side. I want to make sure in inequalities x always stays on the same side. All right? Okay, kids.